Welcome, this is 48E video 2, and in this section we're going to look at projectile motion. So projectile motion is basically free fall in the y-axis and constant velocity in the x-axis. We say a projectile is in free fall, so only the force of gravity acts on it. No air resistance and no foot kicking the ball, no gun firing the bullet, just the pull of gravity. So the effect of air resistance is to be assumed negligible. The acceleration is not greater for heavier objects. As we said with free fall, that's a not obvious thing. A small object is a small force, a big object is a big force. One might think that there's a big acceleration for the big object because there's a big force. But it turns out that the big force of the weight is caused by the mass of the object. And so if we say A is equal to F over M, if that force is caused by mass, then because we have the effect of mass on the top and the bottom, a big mass and a big mass, the effect tends to cancel itself out. So all objects accelerate downwards with the same acceleration. I've said here 9.8, which is the more precise value. In my classes we use 10 meters per second squared. A projectile follows a two-dimensional path, which is a parabola. If we look at a typical path, we can see it here. It basically follows this arc. The acceleration in the y-axis is minus 10 meters per second squared, just as in free fall. The acceleration in the x-axis is 0 once the object has left a firing device. This tends to be conceptually a bit hard for people to consistently remember. We're so used to living in a friction-filled world where you have to keep pushing to continue motion that we associate motion with a force. And it turns out that the object, once it's free of the firing device, just coasts sideways with no acceleration. We must consider the projectile's vertical component of motion independently from its horizontal components. So we work vertical axis, horizontal axis in these things, both independently. The projectile travels sideways for as long as it is above the ground. So often the duration of my journey is determined by the vertical components of my journey. And when the object finally reaches the ground, it stops moving sideways. And the vertical axis governs the duration of the journey. Let's look at some questions. A ball X is kicked from a level ground at an angle of elevation of 30 degrees above the horizontal. Look at that language. An angle of elevation of 30 degrees above the horizontal. That's, physical science or engineering talk. The angle of elevation of 30 degrees above the horizontal axis. Assume air resistance can be ignored. With what angle will the object approach the ground? So what is this angle here? In our day-to-day lives, because of air resistance, the chances are that the object will tend to fall down on us. We see this at the beach with a beach ball. Because of air resistance, we tend to find that the ball tends to fade and just fall downwards. But that's because of air resistance. In the absence of air resistance, what we find is a symmetrical journey. And so we find that the angle with which the object approaches the ground will be 30 degrees elevation below the horizontal. But it gives me 30 degrees here and 30 degrees there. Conceptual question, yeah? Next one. A cannonball is fired with a muzzle speed of 4 meters per second. So this is 4 meters per second. Horizontally off a cliff. What is its acceleration in the horizontal direction? And the answer is 0 meters per second squared. It's not minus 10 because that acceleration is in the vertical axis. And it's certainly not plus 10 meters per second squared. So neither one of these two is right. The answer is 0 because there's no net force acting horizontally. The only net force acting on this particle is the weight, and so there's only an acceleration in the vertical axis. Let's look at another one. A cannonball is fired with a muzzle speed of 4 meters per second horizontally off a cliff. It takes 3 seconds for the cannonball to hit the sea. So my delta t equals 3 seconds. What is the final velocity in the horizontal direction? What is my horizontal component of velocity at the end? Well, if there's no acceleration horizontally, because there's no net force component horizontally, then I have no change of velocity horizontally, and so my final velocity is the same as my initial velocity, and so I have plus 4 meters per second. The speed is constant horizontally. A cannonball is fired with a muzzle speed of 4 meters per second. So VI equals 4 meters per second. Horizontally off a cliff, it takes 3 seconds. Delta T equals 3 seconds for the cannonball to hit the sea. What is the range of the cannonball? So the range is the horizontal displacement. So, okay, let's list what we know. First of all, we have to decide, are we talking about vertical information or horizontal information, because we can only use one or the other in any equation. Well, find R, which is horizontal, using horizontal info. If you're looking for something that's horizontal, use horizontal information. If you're looking for something that's vertical, use vertical information. What do I know horizontally? Well, VI is equal to 4 meters per second, and it's positive. I know that my duration for this journey was equal to 3 seconds. I want to find my delta x. I've given it the letter R, but I don't know what it is. What else do I know? Oh, I know my acceleration horizontal, and my acceleration horizontally is 0 meters per second squared. It's not minus 10 because we're working horizontally. So we say, what links these things? Delta x equals VI delta t plus 1/2 a delta t squared. So delta x is equal to plus 4 times 3 plus 1/2 0 times 3 squared. So delta x is equal to plus 12 added to 0. So delta x equals plus 12 meters. So my range is equal to plus 12 meters. Now some people are saying, oh, of course, yeah, 4 meters per second for 3 seconds, 3 fours are 12. I've got it. And yes, intuitively you know how to do it. But when things get more complicated, you need the formalism of the equations. So watch out for that. Another couple of questions. A cannonball is fired with a muzzle speed of 4 meters per second, horizontally off a cliff. No diagram now, notice. 4 meters per second, horizontally off a cliff. It takes 3 seconds, delta t equals 3 seconds, for the cannonball to hit the sea. What is the height of the cliff? Oh, height of the cliff. It's the same setup, but a different question. And so I have to say to myself, find h using, well, vertical information. H is vertical, so I have to use vertical information. So I make a list. What do I know vertically? Well, I know that my displacement vertically will equal h, but I don't know what that is. Vertically, there's my start, and here's the end. And I know my displacement will be equal to h meters in length, but I don't know what it is. Oh, I know my acceleration. My acceleration is minus 10 meters per second squared, because I'm talking vertically now. I know my duration. My duration is equal to 3 seconds because I was given it. I need one more thing. And I actually do know one more thing, but it's not perfectly obvious because it's never mentioned. And that is that my initial velocity is equal to 0 meters per second. It's not equal to 4 meters per second. That's the horizontal initial velocity. It was fired horizontally. It wasn't fired slightly upwards. It wasn't fired slightly downwards. It's the same as a diver stepping off a cliff. The initial velocity vertically equals 0. And so, can you see how some of these are not obvious until you practice them? You have to practice them. And so I say, well, what's the equation? And as is often the case, we tend to use the same equations over and over again. Delta x is equal to vi delta t plus 1/2 a delta t squared. So delta x is equal to vi is 0 times delta t, which is 3, plus 1/2 times minus 10, minus because it points downwards, times 3 squared. So delta x is equal to 0 plus minus, well, 3 3s are 9, 10 times 9 is 90, a half of 90 is 45, so that would be more, minus 45. So delta x equals minus 45 meters. So h is equal to minus so now my displacement is equal to minus 45 meters. My height, I'm really talking about a scalar, and my height would equal, I'd put down 45 meters for that. It's not negative because it's not a displacement, it's a height. Let's try the next problem. A cannonball is fired from a level field with a muzzle speed of 40 meters per second at 30 degrees elevation above the horizontal. There's that language again. And my advice is that you try to make the angle look correct. If it says 30, try and make the angle look like 30. There's a tendency we all have to draw all our angles at 45 degrees, and that's a mistake, because when you do 30 degrees, one side of the line is a small angle and the other side of the line going to the vertical is a big angle, and so your diagram can help you in determining the size of a particular angle when you're doing trigonometry. So try to make your diagrams, especially at the beginning of your training, precise. Get a protractor, it will really help. What is the maximum height above the field? Well, the maximum height is here, but I'm actually going to think about this in terms of components. Here's the start of my journey and here's the end of my journey. And I see, oh yeah, find h using, well, it's vertical, isn't it? Vert info. Always write that sentence down. It will remind you in a test. I got to be careful. What do I know vertically? Well, I know that my delta x is equal to my h, which is what I want, but I don't know what it is. I know that my acceleration is equal to minus 10 meters per second squared, minus because it's pointing downwards. I know that my initial velocity is equal to, I know that my initial velocity is equal to 40 sine 30 meters per second. Let me take you to the diagram. Let's just emphasize that. Break it down into two components. I'm interested in the vertical component. Remember, if this is A and this is theta, then this vertical component is A sine theta, and the horizontal component is A cosine theta. You have to practice that to the extent that it's easy. It cannot be the stumbling block of your problem. I need one more thing, and the final thing I have is, oh, VF. Can you tell me what VF would be? Yes, VF is 0 meters per second, because the object's component stops traveling upwards before it starts falling downwards again. That's obvious looking at the component. It's not at all obvious looking at the actual path taken by the object, because it still actually has a velocity at this top point. It's moving sideways. So by using components, it really simplifies and emphasizes what we need to look at. I then have VF squared equals VI squared plus 2A delta x. Oops. If that didn't come quickly, just practice, you'll get it. And I say 0 squared is equal to 40 sine 30 squared plus 2 times minus 10 times delta x. Delta x is what I want to find. So delta x is equal to, it's going to be minus 40 sine 30 squared, because we take it to the other side, and we're going to divide it by minus 20, which equals, and here I get my calculator and I check them on degrees, and I say 40 sine 30. That gives me 20. I square that. That gives me 400. I divide it by 20. That gives me 20. Be very careful with your calculation. Make sure you're comfortable using your calculator. This would be positive and this would be meters. So if my displacement is 20 meters upwards, that means my height must equal plus 20 meters. Let's look at this next one. A cannonball is fired with a muzzle speed of 25 meters per second at 40 degrees elevation above the horizontal. What is its range? Range is a horizontal measure of displacement. So there's my range. And let's start off. I'm going to say find R using, well, I need horizontal information. Hor info. Well, I need to make a list. Looking horizontally, I know my VI is equal to 25 cosine 40 meters per second. I know that my delta x is equal to R, but I don't know what that is. I know my acceleration is equal to 0 meters per second squared, not minus 10, because I'm working horizontally. I need one more thing, and the thing I need is time. Now I know that I need time because I've done these things before. Let's say that you're doing this for the first time. The most obvious thing to say is, oh, I know VF. And the correct answer is that VF equals 25 cosine 40 meters per second, because the horizontal component of velocity at the end of this journey, it's certainly not 0, because the end of the journey is the instant before the cannonball hits the ground. Remember that these equations cannot be used inside the firing device or once the object has touched any kind of object, because the acceleration has changed. So the final velocity is not 0, that's a common mistake. And it is truthfully 25 cosine 40 meters per second. And so it's tempting to say, well, VF squared equals VI squared plus 2a delta x. And the problem is that because a equals 0, the second term disappears. The thing that's multiplying delta x, which is what I want, disappears. And I get VF squared equals VI squared, which I knew already. So it's a correct and truthful equation, but it's what we call a trivial answer because it's not telling us anything we didn't already know. So I need to be careful about that. Let me erase this because it's a blind alley. And it turns out, with some experience, what you find out is, oh yeah, I need to find my time. I don't know it, but I'll sort that out. and I say, well, delta x is equal to vi delta t plus 1/2 a delta t squared. So I say delta x is equal to vi 25 cosine 40 times delta t plus 1/2 times 0 times delta t squared. So the second term goes away. So delta x is equal to 25 cosine 40 times delta t. The problem is, I don't know what delta t is. And if you're a novice, that throws you into a panic. But with some practice, you realize, oh, this is a two-step problem. I can solve it in 2 steps. All I need to do is find what delta t is. Well, how do I find delta t? I've already used up my horizontal list of information. I need to look vertically. Find delta t using vertical info. What do I know vertically? Well, I know that vi is equal to 25 sine 40 positive meters per second. If that's an issue, then you need to review your trig, because hopefully you can see that the vertical component is going to be the sine of 40 degrees. And I know that my acceleration vertically is minus 10 meters per second squared because it's pointing downwards. I'm starting here and I'm going to go up to the top, and then why not let it fall back down again? So I'm going to end at the bottom again. And so my VF is going to equal, well, it will be the same speed. It will be 25 sine 40, but it will be a negative sine, 25 sine 40, because the object is clearly falling downwards. And then I want to find my delta t. So I can say, yes, very nice. VF is equal to VI plus A delta t. So minus 25 sine 40 is equal to VI plus 25 sine 40 plus A minus 10 times delta t is what I want to find. So this gives me minus 25 sine 40 added to 25 sine 40 is 50 sine 40 divided by minus 10 equals delta t. So delta t is equal to plus 5 sine 40. Delta t is equal to, check them in degrees, 5 sine 40, which equals 3.21 seconds. So I found my time. Last step. We move it back up there. But I got no space, so I'll do it at the bottom. Delta x is equal to 25 cosine 40 times 3.21, which equals, check you're in degrees, 25 cosine 40, enter, times 3.21 equals 61.5. I have 61.5 meters and positive. So how do you feel about that? That's a multi-step problem, but it's just a series of one-dimensional motion steps. I tried to solve the problem immediately using horizontal information because I was trying to find something that was horizontal. So I looked at this axis to begin with, and I did that here. And I found that I couldn't solve it because I lacked delta t. And then I said, well, let's look vertically. And that's what I did here. And I tried to solve the problem to find the time using vertical information. And I was successful. And then I simply recombined the two parts. Remember the approach. You'll probably not see this question again, but you'll see something somewhat similar. And I'd like you to remember how you tackle two-step problems. You try the most obvious way. The equations will tell you what you need to find out. You then typically go to an orthogonal axis, a 90-degree axis, to find the missing piece of information. A couple of words about style. Some people prefer to leave these throughout the calculation, and other people prefer to work them out as numerical values as quickly as possible. And there's nothing wrong with that, provided that you don't round too much. If you round too much, then you'll end up with rounding errors. With practice, people just leave them in, but there's no reason. Don't feel that if you want to get them to be numbers immediately, don't feel that you're doing anything badly. Final point. You may have seen this problem before because it's quite a common problem. And you may have learned to look at this going from the start upwards and stopping at the top, because you know the final velocity vertically is 0. But then you got to, and so you can find your time that way. But then you got to remember to double the time, because it takes as long to fall down from the top as it does to climb to the top. If you start at the beginning and end at the top, you've basically taken into account that part of the journey, and you have to take into account the falling time to take into account that part of the journey. So there we have it.